Assalamu alaikum everyone. In today's video we are going to solve question number 1 to 4 of exercise 3.4. This question is is related to skill 3.4. This is again from Cantab Publishers. This is exercise 3.4. So first question is that we need to find out we need to apply three main basically operations, which are union, intersection and difference. Then there are second question is also a proof, third question is, and fourth question is related to Venn diagram. So let's start with question number 1. So in question number 1, set A and B are given and you need to find out different you need to apply different operations on these two sets. So A union B is basically that when you write all the elements of sets, but the common elements will come only once, because this is the property of set that the elements will be only once in the set. So as you can see in this question, A is basically a subset of B. So this property is there that A union B would always be B and A intersection B will be A, because all the elements of set A are part of set B also. So as you can see, A intersection B is basically set A. So this is a special formation. So now let's see what is A minus B. A minus B is basically that all the elements of set A which are not in set B will come in the answer, but we have already discussed that A is subset of B. It means all the elements are already part of B. So I have done rough work also for you. You can do it like this. So you can see there is no element of A left which is not in B, so the answer would be empty set. But you can see B minus A is a different scenario. When you subtract A from B, so the common elements would be gone, but the extra elements would still be there. So FGH would be the answer, and you can clearly see that A minus B is not equal to B minus A. Moving on to question number 2. If A is this set, B and C, all the three sets are given, it is in front of you. We need to prove A minus B. So basically if you look closely, this says basically distributive property. So expansion is there. So let's solve left hand side first. A minus B minus C. So A minus B would be, I have written in detail, I have written both sets so that you can easily see 0, 2, 4, 6 are gone because they are cancelled with B. 8 and 10 would be the answer. So A minus B minus C would be 8 and 10 both are gone because they are already there in C. So the answer would be empty set. This is the answer of left hand side of this question, that is empty. So let's see what is answer from right hand side. So A minus C minus B minus C. Let's calculate A minus C. So you can see that the answer would be 0 and 2. Rest of all the elements are subtracted. B minus C would be 0, 1, 2, 3, 4, 5, 6 will be gone because they are in the other set. So if you subtract the two sets, your answer is empty set. So hence left hand side is equal to right hand side. Moving on to question number 3. Draw Venn diagrams of following: A intersection B union C. So I have used a different method from book, so I hope this is more helpful to you. So I have used different symbols to represent. You can see B union C is represented by a tick mark. So there are 6 basically you can say subsets which are included in B union C. So if I take A intersection B union C, so the 3 portions will stay and the rest will be gone. So next question is A intersection B intersection C. This is the second part. So you can see that this only the common area would be coming in the answer. So then is A minus B union A minus C union B minus C. So I have used 3 different symbols. A minus B is represented by tick mark A minus C is represented by a circle, you can see on there, and B minus C is represented by a cross. So because there is a union, so it means that whatever symbol is there, even if one symbol is there or two, you need to shade all that areas. So it's important to note here that when there are three sets in Venn diagrams, so basically there are 7 subsets, as you can see on the screen also. So 4 subsets are shaded and 3 are unshaded. So this is very important to understand this Venn diagram when there are 3 sets. Alright, so moving on to question number 4. Question number 4 is again question of shading. Draw the Venn diagram to prove the following. So this time the difference is that we need to, through shading, we need to prove that left hand side is equal to right hand side. So in the first part, if I take left hand side, so I am again using 2 symbols. Here is tick mark and a 0 or a circle. So you can see tick mark is there in 6 subsets and circle is there in 4. So the common we need to take, so the only common portions are shaded. For left hand side, I am again using 2 symbols, a cross and a tick. So you can see that you have proved it. Moving on to second one, A union B intersection. So there is a mistake in book in this part. So please make the correction. So it's a distributive property of union over intersection. So the error is in the left hand side, please, right hand side, sorry, please make the correction on the book also. So left hand side is again like this. I have taken 2 symbols, tick and cross, to represent, and because it is union, so all the area would be shaded where the marks are there. So I have shaded all the area. So for left and for right hand side, I have used 2 symbols again. A union B is represented by a tick mark, and A intersection B, A union C is represented by a cross. And because you need to take intersection, so only the areas where both symbols are there, they would be shaded. So you can see I have shaded the areas where both symbols are there because it is intersection. So 5 areas are shaded out of 7. So it is same shading as the shading of right hand side. So hence we have proved this part also. So right, so similar shading, so hence proved. Moving on to third part, A union B union C is equal to A union B union C. Basically it is associative property of union. So if we take left hand side, because it is union of all the 3 sets, so everything will be shaded. So similarly in the right hand side, I have used 2 symbols, you can see on your screen. So everything will be shaded. So both the shadings are same, so hence this is proved. So moving on to next part, which is associative law of intersection. If you see closely, it is just intersection. So only the center part where the common elements which are there in A, B and C are coming, they are both shaded. So you can solve or look closely how I have solved. A intersection B is represented by a tick mark, and when I have taken C also, so only there is one part which is left. The way I told you earlier also, this is both properties of association.